Okay, this is chapter 10, talking about gas laws. You can see your table of contents there. Comparison of solids, liquids, and gases. If you look at just something like density, you find that gases have a much lower density than that of solids and liquids. That's because the gas molecules are very far apart. You can see that in this table where the gas molecules are very far apart. They're more dense than a liquid. And then in the solid, it's sort of interesting. The carbon tetrachloride has a bit higher density than the liquid, but water, it's a little bit less. Water is somewhat atypical where the solid has a lower density than liquid because it expands when it freezes. Most things don't do that. Usually the solid is a little bit more dense than the liquid, which is a lot more dense than the gas. If we want to look at the composition of dry air, so what we're omitting when we say dry air is water vapor, which is highly variable in the air. So we got nitrogen as most of our atmosphere at 78.09%. Oxygen is actually most of the rest, 20.94%. You got approximately a percent left. Most of the rest of that is argon. You have trace amounts of other gases. Carbon dioxide is the next most abundant, which is used in plant photosynthesis. It's also a greenhouse gas. We got our noble gases besides argon, only a bare trace, 0.002%. Methane, primarily produced by organic decomposition or perhaps coming from underground reserves, 0.00015%. And there are trace amounts of hydrogen in the atmosphere as well. Pressure. In the United States, we like to measure pressure in pounds per square inch. Most of the world doesn't, but if you think about your tires pressure, about 35 pounds per square inch for a normal car. That's pretty typical, but that's the amount it exceeds the current barometric pressure. It's sort of a differential. If you use one of those gauges where the little stick jumps out the handle, that's a differential pressure. You're measuring the pressure that the pressure inside the tire, for example, exceeds the current atmospheric pressure. So the pressure you read in the tire could vary a little bit with the current barometric pressure. Most people will use pounds per square inch in the United States, but the metric version is newtons per square meter. There's about 4.3 newtons in a pound, so we're talking about a smaller amount of force per square meter, which is a much larger amount of area than an inch. So that is a ridiculously small pressure unit. But we call that the Pascal, and it's abbreviated PA. Most people, if you see something they want to use metric terms, they'll use the kilo Pascal instead of the Pascal and knock 3 zeros off of that. Atmospheric pressure is measured using a barometer. The 1 atmosphere is defined as the pressure on average at sea level. So all these are equal units, equal to 1 atmosphere of pressure. 76 centimeters of mercury, 760 millimeters of mercury, 760 torr, or torr is just a millimeter of mercury, named after Torricelli, who devised the first barometer. And then there's 101,300 pascals, or 101.3 kilopascals. So you notice why we chop off a couple of decimal places to make the number a little bit more reasonable. And 14.7 psi is equal to 1 atmosphere. And so if we want to convert some pressure units, I'll do gas X. I'll leave gas Y for you to practice, since this is a study question. So if we look at this problem, we can see that we can convert the ATM to PSI in millimeters of mercury and pascals and kilopascals. And so we got 2.50 ATM to PSI, 1 ATM is 14.7 psi. And then that's going to give us 36.7 psi. So we'll fill in the table. And then if we want millimeters of mercury, we can do it all from ATM, or you can use the unit you calculated. Just be careful of rounding error. 1 ATM is going to be 760 millimeters of mercury. And I'll treat that like a number with 3 sig figs. And then that's going to be 1900 millimeters of mercury, or torr if you prefer. This zero right here is still significant. Pascals. So let's 2.50 ATMs. Pascal's 101,300. Really, it's 325. We just rounded off a little bit. Pascal's 1 ATM. And we get 2.53 times 10 to the 5th pascals. And so if we knock 3 decimal places off of that, it'd be 253 kilopascals. And that would complete our conversions. Okay, since we were talking about barometers, this is a mercury barometer. You leave it open to the atmospheric pressure pushes down onto a pool of mercury in our case and pushes it up a tube where we've drawn all the air out. The height of that column of mercury is a pressure unit. That's why we're saying millimeters of mercury. It's the height of that column in millimeters, which is approximately equal to 29.92 inches of mercury. The weather report normalizes the pressure for altitude, and so you can't treat that as an absolute pressure measurement, but it is approximately the same thing as long as you're at sea level or close to it. But it pushes that up, and then the average pressure at atmosphere will rise that column 760 millimeters or 76 centimeters.